What's up? All right. So we are going to look at empirical and molecular formulas, periodic table, calculator. All right. Not hard, but kind of fun problems to solve, especially for new chemistry students, because it's one of your first multiple step problem solving experiences in here. Makes you feel smart, you get good answers, okay? So we are going to talk about the topic empirical and molecular formulas. All right. So the empirical formula, or actually let's talk about what the molecular is first. The molecular formula ratio of subscripts of elements. No, sorry. How about shows the actual ratio of subscripts of elements? All right. They're the actual, the true ratio. The empirical formula, the ratio of elements is in its simplified version. Is in its most simplified form. Okay? So for example, let's say that I have a few molecular formulas. Let's say that I have some actual formulas, right? CH4, C2H6, maybe I have C6H3O6. That doesn't make any sense at all. Probably totally just made that up, right? And let's say that we have C3H12. I don't even think these things would form. That's fine. Our empirical formula would be the simplified version, okay? So for CH4, the empirical formula is the molecular formula. For C2H6, I see that both subscripts can be divided by 2, therefore they can be simplified, and the simpler version would be CH3. For the next one, I see that both subscripts could be divided by 3, right? That gives us an empirical formula of C2H02. All right. And for the last example, I see that this could be divided by 3, and this could be divided by 3. And my empirical formula would be CH4. So look, we can have the same empirical formula, right? But different molecular formulas. Or we could have the empirical formula be the same as the molecular formula. So either of those can happen, all right? Now, if you look at our empirical formulas and our molecular formulas, how would we get from our first empirical formula, CH4, to our second, our molecular formula, CH4? We would times it by 1, okay? The subscripts get multiplied by 1. For my second example, in order for me to get to CH from CH3 to C2H6, I would need to, that doesn't go there, right, to C2H6, I would need to multiply it by 2. And then the subscripts would turn into what they originally were. For my next example, right, I would need to multiply my subscripts by 3 in order to get to go from my empirical formula to my molecular formula, okay? And in the last one, I would need to multiply my subscripts, nope, not by 4, but by 3. Let me get rid of that. I was about to write a 4, by 3. Okay, so what I want you to see is that if we take an empirical formula and multiply it by a number, we get the molecular formula, right? If we take this empirical formula and multiply it by a number, we get the molecular formula. And that continues, right? We took this empirical formula, we multiplied it by a number, and we got the molecular formula, right? And we also did the same thing right here. So an empirical formula can turn into a molecular formula if we multiply it by a number, okay? That number is equal to the molecular mass, the mass of the molecular formula, divided by the empirical mass, the mass of the empirical formula, okay? This will be given to you in the problem, okay? And this you must calculate using the periodic table. Okay, let's look at a practice problem. As a matter of fact, I'm going to do one of these practice problems first. I hope this worksheet is legit. Okay, so why is that so big? Let's look here. Oh, I'm not finished going over your notes. Stupid me. I had a long day, you guys. It's the first day of Christmas break. Okay, so we just talked about how to go from an empirical formula to a molecular formula. And in order to do that, you need to know the empirical formula. So what I need to tell you next, and failed to tell you, was how to determine the empirical formula. All right, well, it's really easy. We're just going to write out the steps. If they give you, or if you are given percentages, you're going to turn your percent to grams. And that's going to be easy because we will assume 100 grams are present. Once we get our grams, we will change our grams to moles. That's easy. We learned how to do it. You divide by the molar mass. Once we change our grams to moles, we will look at all of our answers and we will divide by the smallest. All right, smallest what? Smallest number of moles. Divide all by the smallest number of moles. We will then multiply till whole. What does that mean? That means if we have numbers that end in 0.25s, we multiply by 4. 0.33s, we multiply by 3. 0.50s by 2. 0.67s by 3. 0.20s by 5, etc. Okay? Now let's look at an example. We'll just go with this example here. The percent composition of unknown substance is. If its molar mass is, what is its empirical and molecular formula? Let's write our information down. And we will slowly go through the steps of solving this problem. We must first get the empirical formula. And then once we know the empirical formula, we can easily determine our molecular formula by reflecting back to our question. Okay, that's the percent composition. Since we're given percents, we need to start right here where percents are. If we were given grams, we could just start here, right? If we were given moles, we would just start here, right? But we're given percent, so we'll assume we have 100 grams. What is 75.42% of 100? It is 75.42 grams of carbon. Therefore, this is 6.63 grams of hydrogen, 8.38 grams of nitrogen, and 9.57 grams of oxygen. Yes, it was that simple. We just changed the percent sign or the gram sign because we assumed 100 grams. We now need to convert our grams to moles. So we will divide each one by their molar mass. Okay. Don't do too much rounding in solving these problems. You'll find that you will lose your pretty whole numbers. Okay, so it's really important that you do not round too much when solving these problems. I usually save more digits than normal. All right, now I'm just going to put this in my calculator. I've got 75.42 divided by 12.01. That's equal to 6.2. Because those numbers are large, I'm going to keep them 798. What is that? Moles of carbon. 6.63 divided by 1.01. 6.5644. 6.5644. That's moles of hydrogen. 8.38 divided by 14.01 equals. It's 0.598. That one's not so important because it's not much of a number. Nitrogen, and then 9.57 divided by 16. I get 0.598. Again, that's always a good sign, guys, when I see I've gotten the same number. Not a bad sign. So we took our percent to grams, we took our grams to moles. Now I'm going to divide every answer, all of my moles, by my lowest value of moles. And that here is going to be this number. Okay, because it's the smallest, I will divide everything by that. Oops, I just wrote it incorrectly. 98, 0.598. 0.598, and I'm finding out what those ratios are, what my subscripts are, right? Because I'm at moles of elements in the compound that can come from my subscripts. So the 6.2798 divided by 0.598, the first one, I see 10.5 moles of carbon. The 6.5644 divided by 0.598, I see 10.9. I'm going to give that 11 moles of hydrogen. I'm now looking for pretty whole numbers or pretty numbers like this, right? I'm looking for numbers like these here, or I'm looking for pretty whole numbers. That's why I didn't round in the beginning, so that I could see these pretty whole numbers at the end. The more you round, the more you lose this, right? Okay, now I do not have all whole numbers because 10.5 is not a whole number. If I did, I would be done. But because I don't, I've got to go through one more step, and that is multiplying until whole. Whole as in WHOLE. So 10.5, a 0.5 needs to be multiplied by 2. If that gets multiplied by 2, then everything gets multiplied by 2. And this is now what? 21, 22, 2, 2. So I have, this is moles of carbon, moles of hydrogen, moles of nitrogen, moles of oxygen. So that makes C21, H22, NO. Oops, excuse me. And this right here, my friends, this is the empirical formula. Right? Very cool. Very cool. However, we also need the molecular formula. Remember that we said the molecular formula can be found or determined, or you get it by taking the empirical formula and multiplying it by some number, right? A number, N. And we said that N can be found by taking the molecular mass, and we said that that would be given, and dividing it by the empirical mass, and we said that we need to calculate that using the periodic table. Okay, so the molecular mass is in fact given right here at 334. And if we take our empirical mass, right, this right here, and calculate it, right? Oops, sorry. We take this and we calculate it. We have 21 times carbon, right? We have 22 times hydrogen. We have, oops, I forgot to put my 2 there, guys. 2, 2. Glad I saw that. We have 2 times, I'm going to go back to my pretty blue color. We have 2 times nitrogen. And we have 2 times oxygen. And we want to add those up together. These are moles, these are moles, these are moles, these are moles, so that those will cancel and we'll be left with grams. 2 times 16 equals, plus parentheses, 2 times 14.01, close parentheses, plus 22 times 1.01, close parentheses, plus 21 times 12.01, close parentheses. And I've got a molar mass here right at 334. Notice that the molecular mass is also 334. That means that our molecular formula is actually the same as the empirical formula. Okay, if I had gotten a 2 or any other whole number, I would have multiplied these subscripts by that number, and that would have been my molecular formula. But since I got a 1, we see that they are identical. Okay, we'll practice that. I have a fun activity, I think, if I can find it. Good job. Good job. Not hard, just a lot of steps.